Welcome everyone and everyone who may be watching live stream online to this edition of our Friday forum. My name is Martin Hedrisch. For those of you who don't know me, I'm one of the members of the Faculty Advisory Board to the Center for American Architecture and Design, who run this forum not quite every 2 weeks, but I would say we have about 6 or so per semester, where the goal really is to sort of provide a forum for exchange of ideas maybe that are still a little bit in progress, for discussion and to get to know what both kind of people inside the school are working on, but also kind of to disseminate sort of like ideas to a kind of larger community. That's why I'm happy we're kind of streaming these as well. For today's forum, I am happy to introduce Tyler Swingle, who is one of our 2 current emerging fellows in design. And now I actually have to sort of like look at my little sheet here. So Tyler Swingle holds the Emerging Scholar in Design position at UT Austin. And he received a Bachelor of Environmental Design degree from Montana State University in 2012 and his Master's of Architecture degree from the Massachusetts Institute of Technology School of Architecture and Planning in 2018. During this time, Tyler won several prizes, including the AIA Henry Adams Medal in 2018 and the Sidney B. Karofsky 37 Prize in 2016. Tyler has worked at Barco Leibinger Architects, a firm that I know and respect a lot, as I have told you, and Matter Design, and has a wide range of project experiences, including awards, or winning competitions, material research prototypes, and build work. Simultaneously, Tyler lectured at the Peter Guohua Fu School of Architecture and at McGill University, and held the visiting scholar position at Montana State University School of Architecture. So I'm very happy to welcome Tyler today. And I will sort of just recede into the background for the time being and let you do the talking.
Great. Thank you very much. So thank you. Okay, great, thanks for unmuting me. Yeah, thanks for allowing me to be here and present on this land that's long hosted indigenous peoples like the Tonkawa, Comanche, Apache, and Cohotican people. Thanks the School of Architecture for allowing me to be here, faculty members, mentors, colleagues, CAAD, of course, and then there's the technical support, which I really appreciate, to my RA and Cal Tompkins, who's in Montana at the moment, finishing up some research projects that we're doing, and then finally for some of my students, like I see some familiar faces here, which is really nice to see. Being an emerging scholar, I will present a lot of the stuff that I'm trying to think through, and most of these are, at the moment, the forms of courses, and some of them projects and things have started to emerge from them. So I'm kind of hoping from both faculty and students, if opportunities come up for maybe like some sort of design to spin off of that, or maybe something that just piques your interest, I'd really like to hear some feedback, because I'm trying to push a boulder, basically, and that's a tough thing to do. So with that being said, we'll just get right into it. So I'm really interested in tools, and I'm interested in them because they all come with biases. This is especially true within architecture, where we have so many tools like modeling software, fabrication techniques, and materials that not only exist, but they influence our design decisions. And these influences come in the forms of standards and conventions, economies and capitalism, and now biopolitics and like the cultural productions of race and gender now. And so with these inherent biases, I'm interested in and then critical of the role tools play in producing architecture. And so within my very short time of teaching and researching, I've tried to dismantle and interrogate this connection between the tool and the creative or the intended product, and try to break those 2 things apart. And so this has arguably created a promoted critical thinking through design practices, but then also produced some new modes of teaching, research, and design altogether. And in order to do this, this often includes like a weird misuse of the tool in order to work through separating the tool from the intended product. And currently, I'm really not satisfied with a lot of these definitions of misuse. I think they're quite negative in that sense, so I started to write my own. And they are, so number 3 is the intentional use of something to produce unexpected or unimagined results, so not necessarily negative. We'll see other people are starting to get at this from earlier in their careers. So Michael Hayes in his Architecture by Numbers was trying to, he called it architecting, which was super confusing for architects because we think we know what we do as architects, but he just wanted to reuse the word. But he called it the intentional production of a present difference out of pre-existing traditions. We might look also to Robin Evans, who we'll talk about in a little bit, and his idea of translating drawings from buildings and this opportunity that it has in this translation. So I guess I'm just calling it something else in that sense. And often, speaking of Robin Evans, I think about this woman painted by Giacinto Brandi in the 18th century. So Robin Evans introduces her in translations from buildings to drawing. And honestly, she's one of my favorite architects at the moment, although I don't know any work that she's done. And I may never know any work that she's done. So she's introduced by Evans because he's trying to imagine the manner in which he hopes architects work and draw, obviously with tools. And while this image has many contextual meanings and implications, his focus that the image embodies is the method of subterfuge and evasion of architectural conventions that are typically our biggest strength and our biggest liability. So in other words, he's arguing for a powerful opportunity of kind of undermining these conventions that we have and then resisting, and so here's my words, and resisting the biases and with spatial intention. And I think he chooses this image because a picture is worth 1,000 words, basically, and he embodies into this certain look, arguably, it's intentional, it's clever, it's mischievous, there's like a serious playfulness to the positioning of the body and the facial expression. And I think all of these things are definitely have the ethos of misuse of how I'm trying to frame it. But one thing that I'd really like to focus on is what she's holding in her hand, which is a divider. And for the students, that is a tool for drawing. And as opposed to Evans's like comparison that he's making, which is the hand of God or the hand of Zeus that comes down and gives the world the right angle, this woman is holding the divider. And this tool, I think, is so important for our contemporary way of thinking because it's a tool that has variable logics built into it. It doesn't do just one angle, but it operates on a gradient between like 0 and 180. It's also sharp and pointy. You can stab things with it. So there's like a lot of things that then come out of this too. And so I try to replicate her and her way of thinking in a lot of the research in my pursuit of misusing architectural tools. Specifically, my interests start to align through ideas of computation, graphics, maps, materials, programs, software, and standards. I know this is like a wide array of things, but I think they all have bits of opportunity for misreading graphics or misinterpreting maps, misusing materials, or misaligning programs. And so what I'll do today is I want to talk about how each of those things start to happen in the 4 courses that I have been teaching. So the 3 on the left are what I've taught so far, and then I'll do creative control in the summertime if I have enough students that sign up. Wink, wink. So what happens is I've tried to put like a bullet point here of the opportunities that each of these courses are trying to provide. So in Dangers of Defaults, which is another software elective, we're looking at the design potentials of errors from the software and also how data inputs and outputs can be used within architecture. BIM is kind of the medium for this. well, in public pool priority, we look at the critical reflection of historical programs, typically ones that embody like segregation, and try to realign those programs. And then also looking at non-binary design methods. So moving away from the modernist dichotomy of inside or outside, but trying to hit that gradient in the middle. Time for timber, which I'm teaching now, and I'm happy to show some in-work progress. So don't judge the work by the students so far. We're only like halfway through the semester, but we're looking at some material experiments as design objects, but then also maps as architectural strategies of ways of connecting with the world beyond just what we have as our computer. And then again, creative control, which will be in the summertime, looks at this translation between digital and physical models. So fabrication and physical simulation. And what I want to do is I just want to start with, I'm just going to start through design and defaults. And so typically this seminar course enhances the design thinking strategies and expands the method of observation for architectural students through the proliferate yet rigid BIM software. This course positions itself as a design seminar, so taking creative aspects from the studio, but then also integrating historical and contemporary scholarship. And then through design exercises, through readings, students are encouraged to, one, embrace errors from the software. They're encouraged to understand misreadings from orthogonal drawings, and they're encouraged to avoid or promote, depending on miscommunication through graphic clarity within their collaborations that they have. So errors are typically seen as problematic, and we were just talking with Keith about like, oh, there's an error, now we have to do it, and we're almost living in a culture of troubleshooting now. And so I'm trying to assess these errors as design opportunities for both learning the limits of the software, but then also developing alternative design strategies that go outside of those limits. So maybe thinking outside the box is kind of this phrase that we might associate with that. So what I really like about this is that not only it looks at the software specifically, but then it simultaneously looks at teaching pedagogy, and it redefines success within teaching pedagogy, because it's not that there's a correct thing that we're doing, but finding an error and working through an error. But then it also works against normative biases of architecture, and we'll get into that a little bit later. And again, this is all work that's been done in the course, so students' names are here, and I'm really happy that they were able to share my work with me. And this is all work that's been produced in BIM, too. So we're not even going outside of BIM, it's just strictly within it. The first assignment asks students to identify errors within the software components, annotation, views, etc., and design alternatives that both undermine the frameworks that are producing the errors and realize the imagined spatial potentials of the identified conflict. So we can see here Marcos's project. I don't want to give too much away because he worked quite a lot on this, and I think the drawings speak for himself, but within BIM he was able to control a colorful surface that was then starting to make a series of patterns here. Along with schedules and lists, BIM software also produces 2D graphic representations and 3D models to communicate their designs. So the course surveys the representation outputs of BIM software, so both 2D and 3D representation. And we'll get to the 3D in a little bit, but I want to focus on the 2D because there are emerging technologies like VR, and AR that rely on literal complete models of the BIM software. The 2D representation relies on abstractions of patterns, line weights, and notations to communicate design as materials and construction methods. So along with techniques of projection, these orthographic and axonometric drawings offer opportunities for productive misreadings. So Robin Evans argues architectural drawings are generative because they represent both planned materials, physical objects, and operations, as well as abstractions, mediations, and obscureness through obliqueness. So kind of two things at the same time, like something digital or virtual and something physical. They are opposed but not necessarily incompatible. And so within this working contradiction, students are intentionally encouraged to misread their drawings that they're producing from the BIM software and to release ideas of space, of scale, of design, rather than traditionally just representing them. So kind of using it as their own design exercise. So with Patrick in this example, we were looking at moments of like, what are the interesting compositions or potential spatial misreadings that are coming out of this, and how to really like lean into those things. Simultaneously, he's working through Revit and BIM to do this. So it is like a software learning experience that was troubling in its own sense. So in addition to graphics, data sets have also become integral into both design and construction process, so much that the use of the notation is almost being replaced by this one-to-one integration of material and design as a file-to-factory output process. So we're talking like G-code here, 3D printing maybe, stuff like that. So that being said, schedules and specifications are also still data sets that we have. And they're still integral within design and construction processes that we have today. So therefore, the assignment tries to have students engage and misorder some of these data sets that BIM is actually producing. And so a couple ways that we do this is we'll start to look through Dynamo, that is the numerical ordering system that BIM has within that, but then we also start to pull data sets from the internet, so inputting into BIM, but then also looking at the types of exports that schedules have as well too. So students are kind of familiar with this process, and typically schedules have an export of like, well, this is how much it's going to cost, and this is like the sizing, and this is maybe the weight, but the intention is to, if we can broaden the aspect of this tool, we might be able to incorporate other types of information that might actually be more valuable to us in one of our many crises that we're facing. So if we can start to embed like carbon footprint within certain types of materials, then they're put into the BIM process, we can have then like a very analytical output of a measurement of a building. So like Kielmo starts to talk a little bit about like how much energy we use, and this might get a little bit closer to that if we imagine what the tool could do. I would say this integration of data and drawings also allows designs to belong to none other than architectural objects or events in general, and then to numeracy organizations or patterns in particular, like Hayes was trying to do in his architecture by numbers. So it's a little bit of a collaboration between like in putting the data set into the design process and being able to work with it. And then finally, this course misuses the collaborative aspects of BIM's project sharing to further develop students' methods of observation and critical design thinking. So rather than collectively working together on an agreed upon design proposal, the students are positioned against one another in the shared design space of BIM, and they start to play a game level by level. So what happens here is one student will put in a certain type of formal language using walls or something like that, and then the second student, without verbal communication, first of all needs to analyze, organize, and comprehend what's going on, and then respond to that. And then this takes it through like 10 levels, and so we start to get these like really beautiful back and forths of different types of design comprehension that's happening here within the software. This is also a really great moment too, because the components that students had been developing then become shared and used by the other students. So it's not only that they're using their own components or misusing their own components, but they're now having fresh eyes on a new set of components. So it kind of like doubles. And then finally, this is the 3D. So this is kind of like this form to file process now, where like everything is embedded and it just goes straight there. So like you can scan these with your QR code. We can put them up later. Maybe I'll just pause a little bit, but like this is AR, this is VR. you know, and this really, like, you'll have to accept some things with your phone. So again, this is work from Cal, from Montana State, but like you can, like that process is like really questions how much we really need drawing anymore and what we use drawing for. And if we're going to communicate literal things, we might just use the 3D, but as a tool for imagination and processing and finding new things, I think drawing is quite important for us. And I think this is, yeah, well, I'll just, yeah, go ahead. So I think one thing that I would like to just worry about a little bit with this course is actually anticipating more of a physical output, like more, because I think things are quite digital and the only physicality is like the paper that students are printing on. So I'm like actively trying to look for something that's a little bit more engaging in this, in the physical world. I mean, there's also ideas of potentially artificial reality and like starting to place BIM within, you know, this room, for example, which has been done. But I think engaging some sort of fabrication process would be ideally something that I'm interested in. Again, it's a seminar course, so we only have 3 hours a week, so that's a big ask. So I'm going to talk a little bit now about public pool priority, which is a Design 5 studio that I taught last semester. And while most architectural designs aim to keep water out through details and flashing and vapor barriers, pool designs are aimed to capture, contain, and curate water as wet environments. And so they heighten the individual experience by suspending bodies, reflecting light and sound, and absorbing temperatures, controlling humidity, or also releasing it. And then while socially, they provide a fluid environment that dissolves boundaries of personal space. So this is from Wiltis and his publications about tracing pools through American history. And with such capabilities, it's no surprise that pools and bodies of water have a long history in the built environment. So from sacred to profane activities, ornamental gestures to pragmatic functions, inclusive gatherings to segregated groups, pools can facilitate a variety of cultural practice, some of which were and still are contradictory, opposing, and unjust, actually. So in this studio, we are looking at the versatility of the pool, specifically the ability of architectural components to navigate a lot between a lot of these dichotomies, and explore and emphasize the design exercise and explore those navigations between dichotomies within the exercises. So other dichotomies include that the studio was interested in was public versus private settings, sport versus leisure programs, wet versus dry spaces, warm versus cool temperatures, old versus young swimmers, etc. And the aim is to, like I said, resist these dichotomic thinking inside Austin, Texas. Yeah, and I would say, like, it's kind of crazy, like the US has a really conflicting history with pools too. Like this has been the site for huge moments of racial segregation. So again, like coming up against these histories and trying to understand what forms of the pool influenced and facilitated this types of segregation, and then what can architecture do to actually start to break some of those things down. So we can see Zake's work here, and Zake was really focused on the elderly population at the moment, and what he did was something really interesting. Is he took the idea of the handrail, something that architects grapple with all the time. We don't know how to represent it. Sometimes it's too much in the drawing, sometimes it's too little, sometimes we just leave it out. And what he did is he took this and he leaned into it and he over-exaggerated it and made it a part of the architecture. So it starts to reflect and mirror and mimic all of the formal spaces that he has. So really anybody that does need the handrail when they walk through a design, they actually feel more accessible, like it's more of an accessible thing than actually being like, oh, I'm the one that has to use the only handrail over here. And I think this is a huge, for me, this is like a massive shift in design and thinking about what elements of architecture are accessible and how they change and influence a space. So Mei Li, on the other hand, was really interested in how people learn to swim. And so there, she found out there's a long history of black and brown bodies that are not comfortable swimming. And she went through figuring out what bodies of water actually make people comfortable swimming. So she did quite a sectional study about some shallow pools and then some larger, deeper pools, and then topographically positioning those pools at higher and lower ends to accommodate stress levels when people are swimming. So you can see in this image here that there's really a detailed idea of like how much of the body is in the water that she's drawing here. And of course, then we also look towards this non-binary design also focuses towards the showers, the bathrooms, the changing rooms and stuff like this. And so trying to engage students on this more of a pragmatic level of drawing the bathroom and how do you actually make a really nice bathroom within a pool. So I won't be teaching Design 5 next semester. I'll be teaching Design 3, so things are going to change a little bit. So those comments are probably more towards myself. I just found that out recently. But I think the one thing, the pool, I don't know, maybe Cindy, you can attest to this, but like I think the pool, like it lacks sometimes some architecture, like capital A architecture. So I was thinking about changing the program to a country club or more labeling it as a city club because country clubs also have this past segregation history that I really want to confront. And then Austin has a long history of having like golf courses in the middle of the city. So I think there's a really unique opportunity there. But that I will have to save for another time. And I want to talk about now the Time for Timber studio that I'm teaching at the moment. So this studio is centered around misusing mass timber construction as an architectural strategy to produce novel space and forms while simultaneously engaging both the material sources and environmental effects of the natural material. So we're pretty good at doing the former and not so much the latter. And although typically outside of architecture, the studio embraces concerns of sources and environments as design opportunities instead of disregarding them as design externalities, which most commonly happens. So through a series of material case studies, actor network feminist theories, and site visits that trace the transformation of forest to forest product, the studio questions the common practices, domestication, and fabrication of this virtuous greenwashed material. So there's really like so much to unpack here with wood. I would say that the exercises and the readings encourage students to basically do two things. So one, explore misusing the inherent characteristics of wood to grow, shrink, bend, twist, and absorb in responsive forms. And two, they ask the students to embrace the misrepresentation of mapping multiple members, meters, and materials within forest and timber manufacturing. And then from these two like understandings of both like the material understanding and then the mapping understanding, I think that there's a really strong possibility for like an architectural strategy, like a holistic architectural strategy that happens here. So it's not only form, but it's also where the materials are coming from, who's engaged in producing these materials, how much it costs, everything like that. So honestly, like I'm asking a lot from my students this semester, and I think they've noticed that a little bit. But I do want to share their work because at some point they're like, when are we going to design the building? And I'm like, you already started. Like you started a long time ago. But so these are some of the material tests that Mariana, Osvaldo, and Curtis are working on, and we'll see some of my work that I've done a little bit later. What they're doing is they're doing lamination strategies, but they're changing the grain direction to start to have predictable curving happening. One thing that's really important is that when modeling this, we have to model with the right materials. You cannot, there's no more representation. So almost in that sense, like we're moving away from Evans's like orthographic drawing, and like we're not seeing any more of that like misreading. We're actually misusing actual material. And what I thought was really interesting about this group is that while my research was just starting, it was looking at the whole thing. And what they were doing is they're looking into like splining different lamination strategies together. So super cool. And then finally, there's an aggregation strategy that happens to that. And then just like a very quick formal exercise of what it could look like at the architectural scale. This was like a month's work so far. So like in the first day, we were already in the wood shop doing this. So I was really happy now, and I think their design has like moved along quite a bit from this. But another example of this was I had a student that was Michael that was looking into Dow laminated timber, and typically Dow laminated timber is more or less just straight. And what he wanted to do was find out what is the correct positioning of the dowel so that it can hold the curve the best way possible. So he did a series of tests of like dowel positioning and dowel angles to then create this tower that functions like it's like the typical architectural irony. It's like plan and section. But we were just trying to find a way to like engage the curvature of the tower here and actually start to use it. And so that's kind of like the material aspect of it. And then we started to look into East Texas a little bit here. And we ended up taking a trip to East Texas, which was really great because it provides a cross-section between the forest, the sawmills, the manufacturing, the people that live there. There's Stephen F. Austin University that has a huge foresting school there that just got acquired by UT system. So I'm in contact with some people there, and we're trying to do a project. So we'll talk about that a little bit later. But yeah, so we got a whole cross thread, and we saw actually like material sciences that were coming out of how people are growing trees differently, and then how they're actually cutting trees, and then finally how they're actually processing them. And that led to a series of maps. And so really I'm like pointing to maybe like James Corner in the sense of like trying to make maps as design opportunities. And they have the capacity to reformulate what already exists and describe hidden forces that undermine the workings of places. And so I'll quote from Corner here: through the rendering visible multiple and sometimes disparate field connections, mapping allows for an understanding of terrains as only the surface expression field conditions, a field of complex and dynamic imbroglio of social and natural processes. In visualizing these interpolations and interrelations and interactions, mapping itself participates in a future unfolding. And so, and like just to summarize, like it helps us see things we didn't know were already there. Like we know where a hill is and we know how to draw topography lines, but what we might not realize, and what some of these maps are showing, is that a lot of the machining actually comes from Germany. A lot of the seeds that they're actually planting in the trees are coming from Louisiana. And there starts to not always be design opportunities here, but sometimes there are. And like understanding that the national forest here is an archipelago that's surrounded by private property that mostly want to do timber production, and they don't really have any care for timber ecology, is a big design opportunity, because then the question for some students is like, how do you design an architectural system to encourage private landowners financially, but then also promote ecological design as well too? So there are some moments that start to produce here from these maps. And we're just seeing a little bit more. So private land ownership versus public, and then also the process and the timing of timber. It is two totally different cycles. So one is about 30 years, that's a private landowner and the plantations, while the other one is about 120 years. And so, like, unfortunately, our architecture buildings don't even last 100 years now. So in the sense that if we even start thinking about engaging with the forest, we get on different time scales. And it's not just that moment of like handing the key over to the owner, but we get to think about how long and maybe how many times the building gets to be replicated and redone. So in the vein of mapping, I've asked Evan and Campbell to continue mapping and to start doing like program mapping and continue this like overlay of things. So this is some of their work that's been noted on, and it's moving forward, but I just want to show like then we're seeing some of these like curved CLT panels that are now getting placed on the site in different forms that they have their configurations with. And so to be determined with that. The review's on the 20th, so if you all want to stop by, I would hopefully love to see you. Some things that basically have like sprawled and emerged from the time for timber are something that I'm calling variable laminated timber, which is kind of cliche, but I like it. There's a Fortlandia competition that's happening in the Wildflower Center that I'm trying to do like a small scale prototype of this building technology. And then my hope is in 2024 to then do a design build. So talk about productive opportunities. When we went to East Texas, the National Forest Service were like, hey, we have a bunch of things that we need built and designed, but we just don't have the energy to do it. So I've been in contact with them, and we're trying to discuss some details about actually building some recreation or some not housing, but like sheds and things like this within the National Forest System. So we would obviously be looking at using timber, hopefully the VLT strategy. I need to make sure it works together. So I'm applying for the Fortlandia competition, but let's talk a little bit about VLT. So there's this whole process in like putting and layering wood together. And most of the time, that CLT, cross-laminated timber, is laid together in a 90-degree pattern. And it's also got a dry moisture content. And what I've been trying to do is change both the moisture content and the direction of the grain to produce some predictable curving within the lamination. So I know all the things within architecture, they need to be reliable, they need to be a little bit standardized, they need to be predictable. So I'm still trying to operate within these value sets, but then also give some design control back to the architects in terms of this industrial product. And so what I have this, it looks like a flower. It's not supposed to be, but this research structure that's up in Montana at the moment, and what this is it is a curved structure here, and we're testing it outside to see how well the wood is going to respond to the moisture content outside, because everybody always talks about how much wood changes over time. And actually what we're seeing here is we're seeing, like, although it's been like hit with snow and rain and stuff like that, we're seeing pretty small moisture content movement within the wood. I think there's a couple influences for this. One, Montana's really dry, so any snow that does sit there, it might either go into the wood or evaporate out. So there is some testing that will need to be done here in Texas with the moisture here. But I was hoping that the piece would kind of, what happens is when it gets wet, it will expand. Yeah, so it will come together. Yeah.
Sorry to interrupt, but before you leave the slide, so the curvature we're seeing, are you saying that's entirely done by the orientation of the grain?
Yes.
Wow.
Yeah, so like I brought this model, thanks for asking. So like this was basically a flat press. And a lot of CLT factories, they need to have that flat press because you can't have like all your predictive or all your complicated form work. And so if you're able to like basically program the different layers in the CLT to do that predictive bending, then you can do that. So yes, those are all bending just by the wood properties themselves. And what I like about this model, and I don't like about this one, is there's constant curvature, monolithic curvature that's happening, or monocastic, excuse me, curvature that's happening all throughout that. So it's one curved full piece. And what this model is I don't know if you can see it, but there's a flat part and there's a curved part. So we're actually able to now have a little bit more precision in where we're curling and curving. So that brings me, and it balances too, and I like things that balance. So that brings me to the proposal for Fortlandia is basically like 5 flat prefabricated panels that we could that I'm hoping to do with the research funding and some RAs here at UT. So we can make them flat and we can wet them, and we're not even really changing the grain orientation here. It's just controlling the moisture content. And what that does is those panels will eventually, over a span of like 48 hours, they will curl. And they curl pretty predictably. So we're seeing then like now basically the basis of, or like a series of walls. These are only like 4 feet tall because they're for children. But they are going to then support like a plinth that's on top here that's also going to be the same process, just no curling. And
With a handrail.
no handrail. I was hoping that they can just, well, so interesting enough, playgrounds, I'm sure you know, but playgrounds, they have their own codes. So depending on the ground, you can get up to 4 feet, and kids will, not students. Well, students are allowed to jump off this too, but kids will then be able to jump off of this. So I'm trying, there are little moments in here that I'm trying to have as like little structural moments, but then they pop out the top too. So there's ways of like climbing up through them and climbing around them, but then also just making sure that 4 feet is actually high enough so that anybody in like a wheelchair can also get in there. Parents can spend time in there with their kids as well too. So I'm hoping like this comes through and it starts to develop and be like a first step into something actually being built, and then the design build will then follow up with that, hopefully. So again, like I just want to say thanks for joining in my like commitment to follow this woman. So yeah.
Great. Thank you so much, Tyler.
Yeah. Thank you.